It's going to be theta and 180 plus theta. Now, if you remember when we did this in the first time, we drew it on these circles, right? Okay, and I said that's slow. It took us like 10 minutes to answer one simple question, okay? Today, all we're doing is the circles. Okay, we're going to solve this like just a regular algebra equation, all right? Those three things you will need to commit to memory. Hopefully, they're already there from like a month ago or 2 months ago. If they're not, you have to recommit them to memory, okay? If you need the three circles, you can scribble those down off the board because those are the diagrams I drew for my M class. Okay, that should come ring a bell, I think, right? Y value, X value, slope. If it doesn't, for back in it looks 2 months. Okay, let's get to some examples here. Example 1. Okay, also, do you guys remember right at the beginning of our unit, like 2 units ago, we talked, please tell me I'm not playing a stupid game. Okay, what was a coterminal angle? I don't remember that from like 2 months ago. Yeah. Sort of. Yes, sort of. I'm looking for something else, though. I know what you're saying. You're talking like these things, right? Like yeah, those aren't quite. Yeah, those aren't quite coterminal, though. I know what you're saying. That's like what we're doing over there. What was a coterminal? I don't remember that. Well, coterminal is like I'm going to embarrass Curtis on the basketball team. That's where I dunk on him on a 30-degree angle. How else can I dunk on him? Well, you want to see it? Here it comes. How did I get that second angle that I dunked on him? What did I do? Can I demonstrate again? Here it comes again. Oh. Uh-oh. What did I just give him? 720 is what I gave him, right? But normally it's a 360. What's 360 then going to be for a circle? Well, 1 revolution, right? Okay? You guys aren't into this, okay? You got it then. Also, coterminal angle is when you add the period. Okay, so going back to our graphs, it's going to be when you get to the same point on the graph in the next cycle. That's what coterminal is. Let's get to example 1. We're going to do this with pictures today if we can. Example 1 says, solve 0 degrees is less than or equal to theta is less than or equal to 720. 3 equals 5 sine theta minus 1. So this is what these questions are sort of going to look like today. So 3 equals 5 sine theta minus 1. Now this looks frightening. It is not frightening. You can do it. Oh, Andrew, Ryan, you always get stuck with the difficult questions. And I'll make it easy for you though. If that said 3 equals 5x minus 1, how would you solve for x? What would your first step be? Good. Okay. So good. So what's the first step in isolating x? You're right. Good. Bring the 1 over. Okay. So we're going to call that then 4 equals 5. Because really we're looking to isolate beta is what we're ultimately looking to isolate here, right? But you're going to deal with 1 layer at a time. Callan, what's our next step going to be here now, please? Somebody help me here. If it's 4 equals 5x, what do we do? Divide by 5 first. Okay? Divide by 5 first. I'm going to leave that as a fraction because I'm a math teacher and I don't like decimals. Okay. Madison, it's up to you. What's the next step to get theta by itself, please? Very good. So we're going to say sine inverse. We'll need your calculator today. If you don't have one, you will need one. Albert, what is sine inverse of 4/5, please?
0.01.
Oh, try again. Sine inverse, I think. I think it's sine. Yeah.
Oh, there we go.
That's better. And that's just a good reminder, just for not only you, but for everyone else in the class. On your final exam, if you get numbers like 0.01, just check again to make sure that you didn't accidentally hit the wrong one there. So that's our first angle. This is going to happen a lot. All right? The first angle is 53.1. Using our lovely set of rules that we just copied down, Ben, what's the second angle for sine going to be? That will work, yes. I was hoping you would have said something else, but that's okay. Plus 360, which happens to be the period, I'll write that in there. Ben, using the great powers in your head, what is 53.1 plus 360, please? 4. Okay, things are looking good, but not yet great. I'm going to slow down here. I'm too excited. That's in my domain, and that's in my domain. Just as a reminder here, as I'm going through here, you need to write your domain here, because remember these graphs go infinitely big. Yeah, go ahead, Matt.
Hey, could it be 180 minus?
Yes, and that's what I'm going to do on the other side. The reason I put the line down the middle here was that this is coterminal to this 53.1, but then you're exactly right. On the other side of the equal sign,
So you have to put the coterminal.
yes, yes. Or theta is 180 minus 53.1. Okay. So that's, who's got a calculator? I don't. 126.9, is that right? We'll do a few of these to make sure we're feeling good about this. Are there any questions so far before I keep going here? Oh, I thought it sounded like, what's that? Sorry, Internet, you don't need to hear this. I should probably hit pause so you can't see who's in my class. There's Internet. Okay, are we okay on this before I keep going here? Just stop.
Okay.
Okay, great. So things are looking good for the 180 minus. How do I get the next angle, Colton, to this? How do I get the next angle going downward on the green side? What am I going to do? Andrew, say louder. At 360, okay? The next one, maybe we'll draw a graph at here. Maybe I'll draw a graph next time because, see where this is going to go. So this is going to be theta equals 489, 486. Now, again, these are all good. They're all in our domain. When do I stop? I go over 720. Okay, so if I add 360 to this one again, you get, what is that? 73.1, which is too big.
Why are we doing this?
We're solving equations.
Why are we doing this? What?
Oh, there's so many answers? Okay, I'm going to maybe draw a graph. I'll draw a graph next. Okay, because the reason for this is if you think the way our graphs go like this, okay, right, these are periodic, they go on forever and ever and ever. So all I'm saying from 0 to 720, how many times do you need to start the value? I'm going to do this one without, I'll do a graph, and then we'll see how this goes. I'm going to stop the video, I'll draw a graph, and then we'll go from there.